have an issue with doing that, and we may see that right here. That's kind of cool, right? Pretty exciting. And what happens is, especially also with our cross-section, because our cross-section is actually a little bit in the glide rather than the riffle. So what we are about to see is that if we take that max depth times 2, we are going to come out of this bank. And the entrenchment ratio is going to be fairly big, and it's going to look like this is not an entrenched stream. If we use the mean depth, which we have estimated so far to be 3.3, and we multiply that by 2, we are not going to come out of the bank. And our entrenchment ratio is going to be, it's going to show entrenched. So what I would say is for a stream like this, it is better to use the mean depth. It will represent more of what's really happening than to use a max depth, especially in a glide, which is going to give you, I believe, an artificially high entrenchment ratio.
I was right earlier. I'm just
Does that make sense? Because we started getting all these stream types. When we were doing this early on, we were getting all of these stream types that were E stream types that kind of looked like this. And we were like, this is not functioning like an E stream. This is functioning like a G stream. And we took him to some of those sites, and that's when he shared this. He goes, yeah, he said, you really should use the mean, which is where mean depth, which is what I started with, but it's harder to do in the field without reducing the data. So I'm going to suggest we use the mean depth estimate of 3.3. That'll give us 6.6. All right, so here's how we get the elevation of that. We take the thaw lag reading. What was the thaw lag rod reading? 12.7? 12.7 minus 6.6 equals 6.1. What does that number mean? Yeah, that's a rod reading that we need. So you can put your rod, hey Richard, if you'll put your rod on 6.1. And Wanda, one thing you can look for in your cross section, do you have any stations that had a foresight close to 6.1?
On that side?
Yeah. We need a flag. You got flags? Flag.
536, which was at 39.
39? Alright, so you can start about at 39, and what you're looking for is you're going to move your rod until it beeps. So you're looking for that station and then put a flag there, and then we'll do the same thing on this side, and that'll be our flood zone area. So you're going to want to record this. You can make a note, Wanda, kind of at the end, somewhere down here or up here. You can put flood zone area width or FPW.
Flood point area width.
Equal. And then you can put like an LSTA, that's the left station. Equals, and he's going to give you the station.
I said like 39.5.
There it is.
Yeah.
There it is.
I like that. Don't go like that. And look which way your bank full flag is. So another way you could have done that is just to come to your bank full flag. And, well, no, never mind. You have to get to that. Hey, Richard, what's your station? So Wanda, right, 40.5. Actually, for this, you could call it 40. So what we did, we came up our twice the bank step, and we took that, we have to get a rod reading. So the math to get a rod reading is to take your thaw lag reading from that HI. So now 12.7 is 12.7 feet from the bed right here to that instrument. And so if I take 12.7 minus 2 times 3.3, which is 6.6. That gives me 6.1. That's the rod reading for 2 times the bankful mean depth. You follow that? So that's that flag. So remember yesterday when you were working on your cross section and you were pinning your flood prone area? That's exactly what we're doing now. And there's the next one. 3.3 feet was the estimate that we used of the mean depth. So you can actually adjust this tomorrow when you calculate mean depth. Anybody remember the equation for mean depth? You guys took this home last night and studied it, right? Right. So mean depth was area divided by width. So we don't know our area yet. So that's why we're just estimating mean depth off of our indicator. We could do this another way, just for fun. 12.7 was your Thawag reading, and about 8.4 was your bankful reading. So your bankful max depth here was 4.3 feet. So if I double that, now I got to come up 8.6 feet. That would be a rod reading of 4.1. What's your low top of bank rod reading? The lowest one would be the highest reading.
5.36 copper bank.
So I am almost a foot higher than that. So you at 4.1. So you see how if we use the max depth here, the entrenchment ratio, that flag would come up another foot, and it would be much bigger. That would not be representative of what's going on here for 2 reasons that we mentioned. One, because this is really more of a glide. The ripple cross section will be here. I did not do the ripple cross section here because we need a machete or a chainsaw.
Yeah, they were upset when he broke branches. So.
Yeah, so I compromised for the badge, and since this is a class. But you may have this in real life. This was actually excellent to show. So keep that in mind. If we were working here and it did not matter, it wasn't close, this one's close. So that's why we went back to mean depth. If it wasn't close, you can use the max depth. Sometimes we come out, if the bank height ratio was 1.2, we would come out and go a long way. It wouldn't matter. Does this make sense, or have I confused you?
Saying that our original number that we were finding. What did you get for
Oh, we actually hadn't calculated it. Let's calculate it. So what's your right station?
103.1.
And what was the left?
40.5.
Alright, so write down FP, the width. Alright, let's go down here. Put ER. No, I don't. You might have other data. ER equals 62.6 divided by, what was your bankful width? Oh, we got to calculate that too. What's your right bankful station? Minus the left one. So our bankful width is 46.9 feet. I'm sorry, 56.9 feet. Okay, drum roll. Ready for the entrenchment ratio? Entrenchment ratio is 62.6 divided by 56.9 equals 1.1. Is that entrenched? Moderately entrenched or not entrenched?
A lot? So it's 1.1.
1.1 is the entrenchment ratio. You remember the break between entrenched and moderate? I think we said it. What did you say? Right, it's moderately entrenched. So at 1.1, we're entrenched. You believe that?
Yeah.
Yes.
You've been slipping up and down. Yes.
Right. So right now, you already know, of course you kind of knew it when you came out here and looked at it, that it's incised and entrenched.
Okay.
What stream type is it? Wanda. We have CGF. So the width, let's do the width depth ratio real quick. We'll do an estimate. So your bankful width was 56-ish, right? 56.9.
Yes.
So we'll call it 57. Your estimate of mean depth was 3.3. Your width depth ratio is 17. What's the split? 12. So we're greater than 12. Right? Greater than 12. The entrenchment ratio is 1.1. So it's high width depth ratio and it's entrenched. So what stream type is it? No, it's not steeper.
No.
So the G is less than 12, but you're in the right, you're close. So width depth ratio is greater than 12, entrenchment ratio is less than 1.4. Yeah, it's an F stream type. Now we're not doing grain size distributions, but this is a gravel bed stream, so this will be an F4. Or an FF. We will have to figure that out. So we will talk about channel evolution. We'll look at that as well.